kind of energy source is usually called a battery or cell. It's even marked as dry cell battery, but in fact it's not quite correct. Scientifically, one source of this kind should be called a galvanic cell, and when several sources are used, we call them a galvanic cell battery. We construct a battery of 3 cells, connecting them consecutively minus to plus. The voltage at each cell is 1.65 volts. If we read the voltage of 2 consecutive cells, we'll see that it is double. And the voltage difference at the outer ends of a 3-cell battery is almost 5 volts. This little incandescent lamp hardly operates on 1 cell, but it gets much brighter on 2, since its rated voltage is 3.5 volts. It gets very bright operating on 3 cells, yet it doesn't burn out. Let's clarify why the voltage produced by the battery is proportional to the number of its cells. An electron moves from plus to minus within 1 cell using chemical reaction energy. It has gained some potential energy and now strives to come back to the positively charged electrode, but it's stopped by outer forces. When we close the circuit, the electron uses the wires to move back from minus to plus and releases this energy in the incandescent lamp. In a closed circuit, this process goes on continuously. The current in the circuit is induced by the electromotive force of the cell installed in it. If we connect 3 cells consecutively, each of them increases the potential energy of an electron and it eventually triplicates, which is registered by a voltmeter. Likewise, a lamp releases triple amount of energy with the same charge passing through the external circuit. Early batteries, constructed by Alessandro Volta in the very beginning of the 19th century, had several dozens of cells connected consecutively. In 1802, a Russian physicist, Vasily Petrov, constructed a battery consisting of 2,100 cells. It produced the voltage of about 1,700 volts. He was the first to observe the phenomenon of an electric arc and an electric discharge in vacuum with the help of this battery. The 3 cells in this encased battery are also connected consecutively. That is why it produces the voltage slightly higher than 4.5 volts. 2 of the cells face their plus side in one direction and the remaining one in the opposite direction. The built-in contacts inside the case provide the consecutiveness of cell closure to connect plus to minus without fail. But what will happen if the cells are connected concurrently instead of consecutively? Now the output voltage of the battery is 1.65 volts, which equals single cell voltage. What has changed? Each cell is characterized not only by voltage, but also by the energy stored within it. When the cell is in operating mode, the energy is used up over a certain time period, and then the cell goes flat. Connecting the 3 cells concurrently, we will triple their operating time without increasing the released power.